Now again add new load case, push over in x direction, push over in x, non-linear, mass source, continuous from state, gravity, add acceleration type in x direction, and this is -1. I will show you this why it is -1. If our structure, if we take one factor, then our p delta curve is in negative direction, so that's why I take -1 here. And model case, okay, this is geometry nonlinear, option is p delta. Full load, we have to take displacement control in x direction, and this is how much displacement you want in our structure. In American code they give the formula of this, but we just take 1000, and this is level number 8, and okay. Again for multiple state, okay. Then for no correct analysis we are ignoring this, and for non-linear parameter I am taking 500 steps. Now okay. In x direction, same, you can go and add copy cases, but just change the name in y and y direction, and this is all things are same. This is also same. Now we define our load cases. Now we have to define the response spectra. So go function response spectra, add a new function response spectra RSA, we have to choose the IS code IS 1893, and then add a new function RSA, zone factor 5, soil type is 2, importance factor 1, response reaction factor R value is 5, okay, and then okay. Now our response factor is defined. Now select now I have to define the hinges. So first select all beams, so go, we have to define the hinges, so go and objective types, beams, select. Now all beams are selected. Now go to assign frame hinges, add hinges, ASC 41 17, okay. For beam, concrete beam flesher, select this. In M3 direction, load cases is I am taking dead load only, okay. And this is very important, transverse reinforcement is confirming, okay. User this is a reinforcement ratio, just ignore this. And deformation control hinge loading carrying capacity is extrapolated after point E, okay, and okay. Now for distance 1 it is provided, same for 2 also, so just add same, then okay and okay. Now you can see our hinges is assigned here, you can see here our hinges is assigned. Now again select objective type as a column and select all columns, assign frames hinges, add new hinge, concrete columns. Now there is this is degree of freedom, this is hinges type actually, what kind of hinges we want in our structure. So basically our column is fail in carrying column carry axial as well as bending load, so that's why I'm taking P M2 M3 means it will take P means axial load, M2 and M3 is a load bending moment in both local axis in x and y direction. So yeah, you can see here the P delta value is, for gravity it is dead load, and for gravity and lateral I defined one load which is carry earthquake load in x direction. So then okay. Now again for other end and okay. Now our hinges is defined for column also. Now our hinges is defined in our beam. There is one more option I will show you. First select all the members and go to assign frame, and there is a end length offset. This is very important. You can just select define length. It is showing that our member is fully rigid, means our joint is rigid. So just select rigid zone factor is 1, means 100% rigidity in our joint, and apply, and then okay. Now our hinges is assigned. You can just right click and see. You can see here hinges are assigned. Okay. Now just before analyzing, just check the model, select all, and okay. It is analyzing is there any warning or not. So you can see no warning message are generated. Now okay, and run the analysis. It is actually taking time because non-linear analysis take little bit time. Now our analysis is completed, done. Now just go to display, static pushover analysis, curve. This is load case for gravity. Just push in X. So you can see this is our pushover curve. For American code, you can see this is our pushover curve, and so you can see the displacement and the shear value is given here. And one more thing I want to show you, that what happened, undeformed shapes, display, for gravity, apply. You can see here for deformed shape in X direction, for mode 1 is showing that there is a hinges formation. If we increase the number modes value, means suppose 1000 steps, and apply, then you can see here there is a all green hinges is formed, means most of the hinges are okay. It is in the within the our IO level, so it is okay. Same we have check for Y also. Maximum number of steps is suppose 100, then okay, it is 6, number of steps is 6. So you can see here there is only green hinges, means no member is failed in, and no any collapse prevention or right hinges is formed, so it is okay. Again go and check deform. So this is all about our pushover analysis. We can see the hinges result also. You can see here for gravity, for X direction, this is our hinges, means this is our hinge type, but the structure, our hinge number, which one is it is, hinge identification is in story 1, column 1, hinge number is C1H9. For that particular hinge, this is the result, means our response of the hinge is this, and the hinge capacity defined hinges is right one, so it is within the CP level. So our hinges means our hinges is okay, means our structure is safe. So this is all about P delta analysis.